Greetings, this is Mark Anderson for Kellogg Community College, and here we are with my second part of the Algebra of Functions video. And for those of you using an older worksheet, you might notice that the spacing is different. This is to actually improve my videos by putting everything kind of on fewer screens, but also just to kind of help with some of the cramped spacing that was originally put into the videos. So anyway, let's get into this. We are going to look at f plus g5, and what's great about this is these problems go rather quick, because what we're going to do is we're going to add f to g, but we will do so when x has a value of 5. Now, if you note that if you just came off of the other video, you're probably wondering, well, do we have to find out domain? And no, actually, because the numbers I'm going to give you are going to be legal numbers inside of the domain. I'm not going to give you irrationals. I'm not going to give you imaginary numbers. I'm not going to give you numbers that would cause a division by 0 error. So I'm just going to take f, which is my x squared plus 9, and I'm going to go 5 squared minus 9. I said plus, I meant minus. And then I'm going to add to that my g of x, or g of 5. So this is going to be, 2 times 5 plus 6. And wow, these go pretty quickly, because I'm going to have 25 minus 9, which is going to be 16, plus 10 plus 6, which is going to be 16. And that gives me an answer of 32. And that right there is my f plus g of 5. I'm just adding the two functions, but instead of x, I'm using 5. And again, these problems go pretty nicely, but you got to be a little careful, with negatives. Like this is negative 1 squared minus 9. And then I'm going to multiply that by, since this is f times g there, I'm going to multiply that by 2 times negative 1 plus 6. So this is going to be 1 minus 9. This is going to be negative 2 plus 6. So this is going to be negative 8 times 4, and that is going to be negative 32. So for my third problem here on this three-part problem, I'm now going to divide. And again, I don't need to worry about my domain, because 4 does not break any rules here. So here I'm going to have my f of x on the numerator. So this is 4 quantity squared minus 9 divided by, this is going to be 2 times 4 plus 6. So 4 squared minus 9, that's 16 minus 9, which is 7. And my denominator is 2 times 4, which is 8 plus 6, which is 14. And we would always try to simplify if we could. And so my final answer is 1/2. This is my answer of f divided by g of 4. So yeah, it was quite nice, wasn't it? Let's take a look at the next section. The next section is going to be some good old compositions. We're going to look at composite functions, and what's a little bit discerning is that the book actually uses a different notation here than one I did in my earlier videos. And for those of you who've stuck with me through the course or stuck with me through the videos, noticed like, hey, there's f of g of x. The way that the book has this written in this section is with a little o, so this is f of g of x. I know it looks like fog x, but this is f of g of x, this is g of f of x. And so what we're about to do is we're about to plug g into every instance of f where there was an x. So I think what helps here is to do a little color coding. So what I'm going to do is color code this blue. You see this blue line right here? Because I'm about to take f of g of x. I'm about to take this g of x and plug it into every instance of x in f. Now what I'm going to do is I'm going to quickly go back and forth between two colors here. I'm going to actually use green for my f of x here. So I'm now going to have my blue squared, right, minus 3 times the blue. So going back to blue, I am now going to show you that by the f of g of x is taking this blue, plugging it into x, so this is going to be my 2x plus 1 squared minus 3 times 2x plus 1. So this means I'm going to have to square this. I have 2x plus 1 twice, and this I'm going to distribute here, so this is minus 6x. Whoa, that's going to look a little weird. Let's see if I can save it. 6x minus 3. Alright, so I'm going to do my FOIL here. So this is 4x squared for the first branch. The second branch is going to be 2x. Third branch is going to be also 2x. And the fourth branch is going to be plus 1. Minus 6x minus 3. So 4x squared plus 2x plus 1 minus 6x minus 3. So I'm going to go 4x squared. Then collect like terms, all the 2x's. 2 plus 2 is 4, minus 6 is negative 2x. And then 1 minus 3 is negative 2. This is my answer. I do not need to factor anything out. I am fully finished of doing the composition of f of g of x. Now what I'm about to do is I'm about to take my green equation. I'm about to take for the g of f of x, I'm about to take my green equation. I'm going to take this and plug it into every instance of this over here. So let me get my blue equation started. This is going to go much shorter because my blue equation is just 2x plus 1. And so my x in this case would be the green x squared minus 3. See? X squared minus 3x. And now I'll do my distribution. So this gives me 2x squared minus 6x. And then the plus 1 on the outside is just plus 1. And there it is. There's my g of f of x. Yeah, sometimes they're pretty big and involved, and other times they're just really, really quick. And this was the quick one. Let's go to the next problem where we're going to have f of g of x and g of f of x. So here we have this f of g of x, or sorry, g of f of x, and I'm going to go back to blue here. But in this case, I'm not going to switch colors on you. I'm just going to plug this x minus 1 in for every instance of x, and in this case, it's only one instance there. It's the negative, negative x plus 1 cubed minus 7. Now what this means is that I need to cube this x plus 1 before I can do the negative and before I can subtract 7. So I'm going to do a little scratch paperwork over here on the left and do my x plus 1 cubed. Now some of you may remember the binomial expansion from our previous video, but in case you don't remember binomial expansion, you may just want to write it 3 times and do your FOIL for this one, which is going to be x squared plus 1x, which is 2x, plus 1. There's my 4 cables simplified down to 3. And then I'm going to multiply that by this x plus 1, which will give me 6 cables here. This is going to be these 3 cables on top, so x cubed plus 2x squared plus x, and then down in the bottom, this is x squared plus 2x plus 1. So this becomes x cubed plus 3x squared plus 3x plus 1. And again, as I said, if you remembered your binomial expansion, you got Pascal's triangle, 1, 3, 3, 1. You've got your descending powers of x. So what we now have is this negative of x cubed plus 3x squared plus 3x plus 1, parenthesis, minus 7. So all these negatives get distributed, so negative x cubed minus 3x squared minus 3x. See, this is the negative getting distributed. This last one, the negative 1, and then the negative 7 will make negative 8. And that right there is the composition of f of g of x by plugging the x plus 1 into the equation of negative x cubed minus 7 for every instance of x. Luckily, I'm going to take this dotted equation, this f of x, and plug it into g of x. And by doing that, I just get negative x cubed minus 7 plus 1. And that's it, because this whole thing has nothing operating on it. So the parentheses are superfluous here. And if I take my negative 7 and add 1, so I'm going to now have x cubed minus 6, and that's it. That's the end of that. Well, so for our final part of this video, we're going to evaluate a composite function. Now, there we go. So here's what we're going to do. Oh no, it looks like it runs over. Oh shoot. So this runs over just a little bit. So what I'm going to do is click down as far as I can go and see if I can get all 4 equations. Okay, so now I can get all 4 of these on the screen. So what I'm going to do is I'm going to rewrite what f of x is and what g of x is, just so we can all see this on one screen at a time. So let's see, got x squared plus 4. So that's f of x. Oh, shoot. All right, we'll try that again. So my f of x equation is x squared plus 4, and my g of x equation is 2x minus 7. All right, so now I'm going to change colors here. I'm going to change to, let's go with black. Okay, so now what I'm about to do is I'm about to plug g of 3 into, I'm going to plug 3 into g, and then plug that into f. So I'm going to go g of 3 is equal to 2 times 3 minus 7, and which gives me an answer of 6 minus 7. So g of 3 is going to be equal to negative 1. So there's that. Then I take that answer of g of 3 is equal to 1. I'm going to plug that into f. So this becomes f of negative 1. I'm going to plug that f of negative 1 into this equation. So this is equal to negative 1 squared plus 4. Oh, I really didn't need these parentheses on the outside, but it's okay. Negative 1 squared is 1. 1 plus 4 is 5. And there's your answer of f of g of 3. Oh man, I keep writing these wrong. I'm so sorry here. All right, there's my f of g of 3. That is equal to 5. All right, so there's my final answer there. So now let's do g of f of 3. So I start off with f of 3 by plugging 3 in for f, 3 in for every instance of x and f. So this gives me 3 squared plus 4. That's 9 plus 4. So f of 3 is equal to 13. All right, so 13. Looking good. Now I'm going to plug that into g. So g13 is going to be equal to 2 times 13 minus 7. And that's 26 minus 7. And 26 minus 7 is 19. So g of 13, or now my final answer of g of f of 13, or sorry, 3. Gosh darn it. Shoot. That's going to be equal to 19. So g of f of 3, that looks terrible. But g of f of 3 is 19. I'm going to rewrite it. I just can't leave it that way. G of f of 3 is equal to 19. All right. Good. Now, we're about to do g of f of x. Now, I'm going to kind of partition all this stuff off in black because I'm going to kind of show you one of the cool shortcuts. If you had, instead of starting with problems 1 and 2, if you started with 3 and you plugged g of x into f of x, this is when you have your 2x minus 7 plugged into your x squared plus 4, so that's 2x minus 7 squared plus 4. Well, let's FOIL that out. This is going to be 2x minus 7, 2x minus 7 plus 4, so this is going to be 4x squared minus 14x plus 49 plus 4. So this whole equation then compiles down to 4x squared. The negative 14s make negative 28x. And then the 53 gets at the end because that's 49 and 4. Now here's something interesting. If I'd actually plugged in 3 in for x, so I got 4 times 9 minus 28 times 3 plus 53, I would have gotten an answer of 5. So sometimes starting with part 3 and then working your way back to part 1, it could save you some time, but you got to be rock solid that you got that equation right. Because if you got this equation wrong and then plugged in 3, you wouldn't have gotten in 5 and you wouldn't have known that you got it wrong. So let's do g of f of x. Let's now put my f of x into g. And this is going to be a little easier because my x squared plus 4 is going to be put next to the 2 because that x squared plus 4 is going to get plugged. This is going to get plugged right into that. So it's 2 times x squared plus 4. And that's minus 7. So this yields 2x squared plus 8 minus 7, which is 2x squared plus 1. Now, if I plugged 3 into this equation, would I get 19? Let's go find out. Let's see. 3 squared is 9. 9 times 2 is 18. 18 plus 1 is 19. Oh my goodness. I could have done, by doing this problem, I could have done problem 2 then really quickly. But again, you have to be pretty solid that this binomial is your actual answer because you wouldn't actually know if you're wrong until you got it done. But hey, wait a second, test strategy. Why don't you actually, after doing parts like 3 and 4 on the test, why don't you actually look back and see if these numbers would match if you substituted in a 3 into these problems or whatever number I give you, be it a positive or negative number. you can actually see if you got the problem right. Wow, that's kind of clever, right? Well, thank you again for watching. This has been part 2 of the algebra of functions. And again, I apologize for all the changes to the worksheets if you are using some old ones. But thank you again for watching, and stay tuned for more math videos.